Okay, so in this video, what we're going to look at is this inversion problem. So this you could do with an array also, but we'll see in the with the case of a single linked list. So let us say this is a single linked list, and so we know that we need to traverse a single linked list starting from the head node. So, and let us assume that the data we have are integers. So we say an inversion has occurred for two integers, say I and j, if integer I is more closer to the head node compared to j, but I is greater than j. So what does it mean here? So these are the integers in the linked list. Then 2 and 1. Let us look at 2 and 1. 2 is relatively more closer to the head node compared to 1, but 2 is greater than 1. So we say 2, 1 is an inverted pair. On the other hand, 2 and 8. 2 is closer to the head node compared to 8, but 2 is not greater than 8. So 2, 8 is not an inverted pair. So an inverted pair means the two integer nodes I and j, such that I is relatively more closer to the head node compared to j, but the data value I is greater than j. So in that sense, 2, 1 is an inverted pair, and then 8, 1 is an inverted pair because 8 is closer to the head node compared to 1, but 8 is greater than 1. And 8, 9 is not an inverted pair because 8 is not greater than 9. Now 8, 3 is an inverted pair because 8 is closer to the head node but greater than 3. And 8, 7 is also an inverted pair. Then for 1, it is the smallest of all the integers out there, so 1 is not going to be greater than anything to its right. So basically, you could get the logic by now. So for any integer in the linked list, for any node, with an integer in the linked list, you have to compare it with everything to its right and check if the integer is greater than anything to its right. In that case, we can say that's an inverted pair. Okay, so that's the logic we are going to use, and this is going to be very useful. The logic we are going to look at and the code will be useful for you to do your assignment too, on finding the unique, whether given a list of elements is unique or not. Okay, so let's go over this code and the logic, and then I'll tell you how related it is to the assignment too. So this code I have written in such a way, the code it is displayed here is in the main function, and it is assuming that you already have created a list of a certain list size. Okay, so is it right? Okay, so you already have a list class, a node class, a list class with all the member functions that we saw in this module: insert, read, and all those stuff, delete. Now, so in the main function, you have a list size input by the user and run a for loop to insert elements at each index in the list. So what we're now going to look at is the code to find the number of inversions. Now you are in the main function and you want to traverse the list. Now so in order to traverse the list, okay, we need to know where the head node is stored, because we need to start from the head node and then go further down. So in the main function, we don't know where the head node of this integer list is stored. But if you look at the list class, you see the private member variable is a head pointer that stores the address of the head node. And there is a member function called getHeadPointer that will return the value of the head pointer. Okay, so you can call this getHeadPointer function on the integer list object that we have in the main function, and that will return to us the head pointer value that will be the address of the head node. And once you get the address of the head node, you can traverse the linked list. Okay, so that's the logic we're going to use. So I initialize the number of inversions variable to 0, and we do all these things provided the list size that we have is greater than 1. If the list size is less than or equal to 1, there's not going to be an inversion. So for an inversion to happen, there should be at least 2 integers in the list. So if list size is less than or equal to 1, we simply go to the else block and say as the list size is less than or equal to 1, there cannot be any inversions in the list. Right, so let us go through the code for this right now. Alright, so you first get the address of the head node by calling the get head pointer function on the integer list. So remember, this is an object. Integer list is an object of class list. So you have to use a dot operator and call the get head pointer function, and that will return the address of the head nodes. And you can store that in a local variable called head pointer. Now the head pointer is a pointer storing the address of the head node. So you have to use the arrow operator and call the get next node pointer function to get the address of the node next to the head node. So this is the linked list, and this is the head node. The next node pointer value in the head node is 200, and that's what you're going to get and store that in current node pointer. So current node pointer is pointing to the node next to the head node. So now go through an iterative process. As you can see here, we would need a nested loop because we need to fix the current node pointer at some node and compare the data at the current node to all the nodes to the right of that current node. So we need 2 pointers. One is the current node pointer, and then another pointer called the temp node pointer. That will be the pointer that will keep traversing the list. So we fix the current node pointer at a particular node and then move the temp node pointer starting from the node next to the current node and keep traversing all the way to the end of the list. So each node to which the temp node pointer is pointing to, compare the data of the current node pointer, the current node, with the data of the temp node. So if the data of the current node is greater than the data of the temp node, then there's an inversion, otherwise there's no inversion. So that's the overall logic. So, and we do all these things only if current node pointer is not null. If current node pointer is not null, you simply come out of the outer while loop and just print the number of inversions that we have seen by now. Okay. So current node pointer is not null because it's 200, so you get inside the while loop. So now we try to get the address of the node next to the current node. So current node pointer arrow get next node pointer will give you the address of the node next to the current node. So that is 70, and and assign that to temp node pointer. So temp node pointer will point to that node next to the current node. And check while if temp node pointer is null or not, because in order to do the comparison of the data, the pointer should be pointing really to an existing node, not the pointer value should not be null. So while temp node pointer is not equal to 0, in this case it is 70, so get inside the inner loop and compare the data of the current node. So current node pointer arrow get data compared with the temp node values get data. Temp node pointer arrow get data. So if current node's data is greater than temp node's data, that's an inversion. So in this case 2 compared with 8, but 2 is not greater than 8, so there's no inversion. So we don't go inside the if block. We come out of here and just advance the temp node pointer to the next data node. So temp node pointer arrow get next node pointer will try to get you the address of the node next to the temp node. So that will be 900. So temp node pointer is now set to 900. And now you are comparing again. So check. So you are still in this inner while loop. Check if temp node pointer is null or not. It is not null, so get inside the loop. Now compare current node's data with temp node's data. So current node's data is 2 compared with temp node's data is 1. 2 greater than 1, so that's an inversion. So you can print the pair, the 2 data values, and then increment the number of inversions. So it's initially 0, so now you have seen 1 inversion. So then move the temp node pointer to the next data node, which is at address 500, and compare the values. So 2 and 9, there's no inversion. Then move the temp node to the next data node. So that is 2 and 3 is no inversion. Then move to the next data node at address 300, 2 and 7, no inversion. Then move it down, further down. So again, by the statement, temp node pointer arrow get next node pointer, you're getting the address of the node next to that current node. So it will be 0, and temp node pointer will have 0 now. So and so you come back to the condition, temp node pointer is now 0, so you come out of this while loop, and we are here, we are checking current node pointer, or making current node pointer to take up the address of the next node. So current node pointer arrow get next node pointer will get you the address of the node next to the current node, that will be 70. The current node pointer will now be made to point to that node, so it's 70 is the value of current node pointer. So now we are back to the beginning of this while loop for the current node pointer. We have 70 as its value, it's not null, so we get inside and again create the temp node pointer. So current node's next node pointer will be the value of temp node pointer. So current node's next node pointer is address value is 900. So that will be the value of temp node pointer, so it's pointing to that node. And then it's not null, so you get inside the loop and start comparing the data. So current node's data is 8, temp node's data is 1, 8 greater than 1, so that is an inversion, so we can print it as an inverted pair, and then move the temp node pointer's value to the next data node. So it will be 500, and compare 8 with 9, 8 is not greater than 9, so it's not an inversion. Then move temp node pointer further down, 700. We have 8 and 3, that's an inversion, so you print the inverted pair. Then move further down, 8 and 7, that's also an inversion. Then the next node pointer value for this data node is 0, null, so temp node pointer will now get the value 0, so you really come out of the inner while loop. So when you come out of the inner while loop, move the current node pointer to the next data node address. So that will make it like what? Current node pointer will now take up 900 as its value and point to the next data node. So you keep on going through like this until you reach a situation where current node pointer is at the last node, say at address 300, it's pointing to this node at address 300, and in that case you get inside the loop, 300 is not null. Now you try to get the address of the node next to the current node, so that will be null because there's no node further down after this node. So temp node pointer will be 0 to begin with, so you don't go inside the inner while loop at all, and then come out and then advance the current node pointer to the next data node. So the next node pointer value for the current node is null, so current node pointer will become null now. So go to the beginning of the while loop, it is null, so the condition is not equal to 0, so it's not satisfied anymore. So come out of the outer while loop and print the number of inversions you have encountered by then. Okay, so how is this related to your assignment 2? That is like, so you want to find if the given list of elements is unique or not. So you see here, this list has unique elements 2, 8, 1, 9, 3, 7. So you could use this a similar logic. You fix the current node pointer to be at one node, and then move the temp node pointer to all the nodes to its right. So use the temp node pointer to traverse all the nodes to the right of the current node, and then compare the value of current node's data with temp node's data. If the two data values integers are not the same, then the list is unique until then. If at any situation the current node's data is equal to the temp node's data, then it means the same integer is appearing more than once in the list, so that means the list is not unique. You can stop your code right there and say its list is not unique. So if the comparisons are indicating the elements are unique, different, then keep comparing all combinations, in the sense that you fix the current node pointer as your first data node, compare its data with everything to its right. Then advance the current node pointer to the next data node and compare that data with everything to its right. And then after done, then again move the current node pointer to the third data node, compare everything to its right using a temp node pointer. So you should understand that you need a nested while loop like what we just had. Okay, so with the first with the first current node pointer, with the first data node being pointed to the current node pointer, you're comparing 2 with 8, 2 with 1, 2 with 9, 2 with 3, 2 with 7. So far everything is unique, but it's not but it's not sufficient. You need to compare 8 with 1, 8 with 9, 8 with 3, and 8 with 7, right? Because it may be possible that there may be like the last two data nodes have 3, right? So in that case, you would not be able to find that out until you make the current node pointer to be at this node, and then set the temp node pointer to the next data node, and then compare the two node data values. Then only you'll be able to catch this. You will be able to catch this last two nodes having the same data values. Okay, so that's why you have to use this nested loop logic of fixing the current node at one data node, and then moving the temp node pointer all the way to its right, and then move the current node pointer to the next data node, and then move the temp node pointer all the way to its right, from traverse all the nodes to the right of the current node. Okay.